Okay guys, so today we're going to be looking at how an object can be charged, or how it can change its charge. Little Puss is here, she's just lying down just to the left of camera, so don't fear. Hopefully we'll visit her later when she needs to put in her physics input. So, for now, we're just going to start off with the basics, that something can either be, and I write this shorthand, positive, or it can be negative. Now, those are the two, or it can also be neutral. Sorry. It could be positive, negative, or neutral. So, to become positive, negative, or neutral, it needs to change its charge. And the way it changes its charge is by the number of positively charged subatomic particles or the number of negatively charged subatomic particles. So, the positive ones are called protons. They're in the nucleus, and the negatively charged ones are called electrons, which are represented here by the two circles, blue and red. So, yeah. Now, the next thing to know, this is one of the most important parts, is that if something is going to change its charge, it can only move the electrons. So only the electrons can move, because they're in the shells around the outside of the atom. They can be moved, and they can be moved by friction. Now, here we've got an example. So this, let's say this is a long rectangular object, and it's got 3 positively charged subatomic particles and 3 negatively charged subatomic particles. So if it's got the same number of each, we've got 3 positive and 3 negative, we're going to have a neutral overall charge, because they balance each other out. 3 positives, 3 negatives balance each other out, and so they make it neutral. However, if we were to remove one of these electrons, it would change, because now it's got more protons, more positively charged things in it. So therefore it is a positively charged. So overall it has a positive charge because it has more positively charged things and negatively charged things. Now remember, we can't take away one of these positively charged things. They have to stay the same. The only thing we can move are the negatively charged things. So what about if we restored it back to being neutral for a little bit? We put in the same number of positively charged things as negatively charged things. Now what about if we added, let's get rid of this for a second, if we added another negatively charged thing here? What about if we added another negative there? That's a negative, it's not positive. Just looks a bit rubbish. What about if we added another negative? Now, let's count up how many positively charged things and how many negatively charged things there are, and then we can work out what the charge is, the overall charge of this object. Now, we've got 3 positively charged things, because we can't move those, can't take those away. But there are 1, 2, 3, 4 negatively charged particles here. So therefore there are more negatives than positive, so we can say the overall charge of this is negative. And we can even say how much negatively charged this thing is. So we could say it is negatively charged 1. If we added another, if this object managed to gain another electron, another negatively charged thing, it's now got 2 more negatively charged things than positively charged things, so it would be negative 2. So it's really actually not too complicated to work out, but the main thing that we have to remember, and it's a really important thing they love asking about in exams, is, and it's the bit of information about that you need to know, that only the electrons can move. Protons, just about to see that. Protons stay. There you go. And just to prove that we weren't fibbing, here she is. You alright, little puss? Hey. Hello. There she is. You're a good girl. Let's see if I get bit. Oh, okay. Fist bump. Nice work. Yeah, cheers. I know, it's been amazing, isn't it? Oh, and you get a bit of belly action. Oh, yeah. putting lots of input into positively or negatively charged objects. Cheers, little puss. See you later.